All right. I think it's recording. So close enough. All right. So first thing we need to do is we need to make sure that we can find the series solution of a differential equation. All right. So let's take a look at something basic, like y prime plus y is equal to 0. Y at 0 is equal to 1. Okay. If you guys were to solve that, e to the negative x, that's a pretty obvious solution to that. Okay, we've solved that plenty of times in class. All right, so let's do this first. Let's go ahead and just get the analytic solution or the regular solution. Okay, so and that's what I'm going to ask you guys to do. So I'm going to clear all and do a clear the screen. So clear all. And then I'm going to define a couple symbolic variables. So I'm going to define x and y at x. I'm going to call my equation diff y comma x plus y equals 0. Okay, so you might remember from the first MATLAB assignment, whenever you define a derivative, it's diff yx, y comma x, and then the double equal means the assignment for the equation. Okay, and then I'm going to define a condition. I'll say condition is going to be equal to y at 0 is equal to 1. And then I'm going to desolve this. Now I'm going to call this the A-sol, the analytic solution. Okay, so I'm going to say desolve EQU, comma COND. All right, and then this code, I'm just going to run this just because I just want to run that really quickly. That should give us the analytic solution. Okay, and I think you guys can see it's e to the minus x, which we already knew, right, guys? That's not like earth shattering or anything like that. You guys could easily do that. But let me show you guys how to get to the solution for a series for this. Okay, so this is the code that's going to be new. So I'm going to say S sol 4. Okay, so I'm going to get like a 4th degree polynomial to represent that. Okay, so I'm going to say desolve again. And I'm still going to have EQU and cond. And then what I'm going to do is I'm going to type in this third parameter, okay, not ignore analytic constraints, but expansion point. Okay. And then I'm going to say comma 0. Okay. What this does is that it's centered about the point x sub naught equals 0. Okay. So remember, guys, if you don't find a series solution, you have to have a central point for that. Okay. So I'm solving this about the ordinary point x naught equals 0. Okay. Now, the other thing I need to do is I need to tell it what's the degree of the polynomial, right? Because we know that these are infinite series. So the last parameter that I'm going to use is hyphen order, comma 4. Okay. Now, let me go ahead and run that for you guys. Okay, and what you'll notice at the very bottom here, and I know it stinks that it's all the way at the bottom, okay, but that is the series solution, the 4th order of that. Okay, let me bring it up a little bit. Nick, I know it's tough to see, sorry. So I don't know if that helps or not, but yeah, so that's our series solution. Okay, it's supposed to be 4th order, it goes out to the 3rd order, but obviously we want a higher order than that, right, guys? The higher the degree of the polynomial, the better the representation of the series, okay, of the original function. So I'm just going to copy and paste this. And this is what I'm going to ask you guys to do for the assignment is I'm going to ask you guys to find a 5th, 10th, and a 15th degree polynomial. I'm going to do 4th, 8th, and 12th. Okay. So I'm going to call this S sol 8. And I'm just going to get an 8th degree polynomial. So the only parameters I'm changing, guys, is I'm just changing the name of the variable and I'm changing the parameter of the order. Everything else stays the same. And if I run that, okay, there we go. We get, it's a 7th degree polynomial. I mean, it's good enough. Okay. At that point, it's probably not much different. And then if I want a 12th degree polynomial, I'm going to copy and paste this. All right. And let me just change this to 12 and change this animal to 12. All right. And then I can run it obviously and get the 12th degree polynomial. So I've got all the degrees of the polynomials here. Okay. So that's how you guys can find out what the series solutions are going to be using MATLAB. Okay. Now, of course, what we want to do is we want to try to plot these on the same graph. Okay. Hopefully you guys remember from Calc 2 that as you get the order increasing, it gets closer and closer to what the actual function looks like. And we know what e to the minus x looks like, okay? It's just reflected in the axis. So here's what I'm going to do, guys. I'm going to suppress these, all right? And I'll get a really nice statement. I'll get an fprintf statement. Okay, and I'm going to say the actual solution is %s, all right? And then I'm going to do a /n, comma, a sol. All right. Then what I'm going to do, let me make another fprintf. Okay. And I'm going to say the 4th degree solution is %s /n, and then comma s sol 4. All right. Now, this is just a print statement. This isn't a graph, but I'm getting there. Okay. Then I'm going to copy and paste, and I'm going to do 2 more of these. And all I'm going to do is just change this to 8th and 12th, and then just change this to 8 and 12. And we'll get a really nice output statement instead of the garbage that we got before. Okay. I mean, it still looks like garbage, but it's better. So then we have a really nice statement instead of just having, like, something crazy there. Okay. So that might be a way for you guys to format it really nicely, especially for those of you guys that are doing reports in your engineering classes or physics classes. This might be helpful for formatting. Okay. Now let's plot these. Okay. So it's easy to plot these. No pun intended, because we're going to use easy plot. All right. So I'm just going to use easy plot. And then I'm just going to plot the a sol. And you guys might remember we use this function hold on. And then I'm going to easy plot. We call it s sol 4, I think, was the variable. And then what I'm going to do is I'm just going to copy and paste this a few times and change this to 12. I'm sorry, 8 and 12. Doesn't matter, whatever order. And then the last thing I need to do is a hold off. All right. Now let me go. Oh, and I'm going to call this figure 1. I'm going to ask you guys to do 2 of these on the assignment. Okay, so let me go ahead and execute this. And then every time I do a figure, it just takes a while to do it. All right. So what you guys notice in the diagram is that it's a pretty good, like around 0, all 3 of the solutions are really good. This yellow line looks really good, doesn't it, guys? Okay, it's really curved, but there's only 2 solutions, right? I only see this orange line and the yellow line. Okay, there's actually a third one for the 12th degree polynomial. It's actually overlapping the exponential curve. Okay, so it's actually convergent there. Okay, one other command that you guys can use, check this out, is you can use legend. And what you do is the order in which the functions are plotted, you just give them a title. Okay, so for instance, we had the analytic solution. And then we had the 4th degree. Okay. And then I'm just going to copy and paste this. And then we had the 12th degree last and the 8th degree third. All right. And then if I execute this, it's a little bit more helpful, because then we can figure out which polynomial represents which. Okay. And I know it's tough to see, especially if you're in the back, but you guys can see there's like a purple line that's the 12th degree polynomial. There's a blue line that's supposed to be the analytic solution. You guys can't see the blue line, right? That's because the purple line the curve, it's not a line. Okay, how dumb of me. But the purple curve is actually the exact same thing, okay, at least from the domain we're given, as the analytic solution. So as we know, as we increase the order of the polynomial, the graphs start to converge. Okay, and you guys probably remember that from Calc 2 with power series. And if you don't, now you remember it. Okay. All right. So that's literally what I'm going to ask you guys to do. Okay. And then I'm going to ask you guys to be able to put together like some labels on the graph. All right, just to make sure. So I'm going to close this. I'm just going to remind you guys really quickly. No, I cannot minimize. Okay. Well, thanks. That's great to know. Let me just remind you guys how to go through and to put some labels on the graph. Okay, so what you guys can do is you can do, remember, X label, you can do X-axis, and then Y, I spelled it wrong. Sorry, there we go. They'll probably yell at me if I didn't. And then we have Y label, we have the Y-axis, and then finally we have a title, and we're just going to say, whatever title you guys want to give this. So we could say series solutions of y prime plus y equals 0. Oh, I can't use prime in there. So let's just say dy dx, right? It won't let me do y prime because I need the accents to be able to make sure we close that out. Okay, so I'm going to run it one more time. And then finally, we'll be done with this. All right, there we go. Okay, so really nice graph. If you guys wanted to, you could probably cut and paste this somewhere, okay, into a report. Remember, you could save these images, okay, if you wanted to. You got to go up here, and then you could save it. I think it's one of these. Yeah, this guy right here. All right, so anyway. All right, now I'm going to ask you guys to do a second order as well. Okay, so let me remind you guys how to do a second order differential. The good news is, guys, all of this code, once you have it for one of them, you can just copy and paste it for the other one. Okay, so check this out. I'm going to close this. I'm just going to copy and paste all this stuff, okay, from the Sims up to here. All right. Now, what I need to do first, okay, so this was the old, that's the new stuff. Okay. What I need to do first is I need to define a different differential. Okay, so let's say for some reason, I was asking you guys to solve this differential. Y double prime plus y equals 0. Y at 0 is 1. Y prime at 0 is also 1. Okay. What we need to do is we need to find a second derivative. Okay. So when I go through and define the function, this is going to be my second derivative. So I have diff y comma x comma 2. Okay. So now what I'm doing is I'm just changing this to y double prime. I'm going to call this condition 1. Okay, and then I'm going to have a condition 2. Okay, and also what I'm going to do is I'm going to define dy to be diff y comma x. Okay, because I need to make sure I have a derivative in there. And then I'm going to have dy at 0 is equal to 1 as well. All right, so what this code right here does, this just defines the initial conditions. Okay, it's just like we did on the first assignment. Okay, but in the video, if you guys want a few more videos, I do have a couple more videos in my library, but I'm going to add this one as well. So you guys have a lot of videos to look through. All right. Now what I'm going to do is I'm just going to solve and I'm going to have the conditions. Okay. So I'm just going to, and what I'm going to do, one nice thing, I need to make a matrix of the conditions. So I'm going to call it cons equals, I'm going to call it con 1 comma con 2. Okay. So that gives me like a matrix of conditions. And I'm going to call this cons now. All right. Now let me cut. I'm just going to cut all this stuff. Okay. And that should solve the differential analytically. Let me go ahead and get rid of that. So I'm going to go ahead and execute it. It's still going to have the same stuff from before, but the last line should be the solution, which it is. Okay. So the solution is just cos x plus sin x. Okay. And you guys know that if you threw that in there, eventually you get negative sine plus sine is 0. Okay, duh. Okay, it's an easy one. Okay. Now, again, once you have that, then you just go through and use the exact same code. All right, so I'm just going to paste this again. All right, so this was the same code. And I'm just going to use the exact same code to be able to derive all of the other graphs. Okay, so the good news is, guys, once you got it for one, it's just a cut and paste. Okay. I'm going to suppress this. I have the same variables, no big deal. I'm just going to call this figure 2 now. And I'm going to say, I don't know if we can use y double prime. I don't know if that'll like that or not. I'll give it a try. All right, let's give it a run and see what happens. All right, so it should give us all of the series solutions for everything. Okay. All right, so there we go. Oh, something it didn't like, line 66. There's the graph. All right, let's see what it didn't like. All right, let me close this. It looked like it was good until a certain point. I wonder if it's this thing. Series solution of the D. There we go. I don't think it was that. but it solved it really nicely. And oh, I see. We had to change all these to cons, right? I forgot we changed the variable name. Okay. It was what it was trying to do was trying to go back to cond when we defined it as a a single parameter instead of two. All right, so let's try one more time. Now it doesn't like me. Fine, I don't like it. There we go. Okay. So here's all of our series solutions. That's nice. Okay, that's great. We go out to the 12th degree or 13th degree. And you guys can see that once again, we have a pretty good representation with the purple curve and the blue curve, right? It seems like right around 4, that's when it starts to diverge, okay? You guys remember that polynomials have far left, far right behavior. And in this case, it's going to go down forever. So it's never really going to match the sine and cosine function. It's just going to do it over a specific domain because we know sine and cosine, it just keeps going like that cyclical periodic sort of nature, okay? All right, so that's what I'm going to ask you guys to do for the hardest parts of the assignment. Okay, so let me pause and just ask if there's any questions before I show you guys the easier parts where we do the Laplace transforms. Okay, those are literally like 3 lines a piece. They're not meant to be tough. Okay. Oh, go ahead, Brandon.
I guess as you increase this degree, the more accurate.
Yeah, always, right. Just like a power series or just like your in Calc 2 when you did your Maclaurin series and Taylor series, right? Hopefully your teacher showed you the graphs of those as it increases. Okay.
I mean, I'm just wondering, I know you probably just asked it like a second ago, but for the orange one, it's not looking like the other.
Yeah, and it kind of curves, like notice that it converges like close to 0, right?
Yeah.
But like the further you get away from that central point, right, around x naught equals 0, then it starts to diverge the behavior. Notice the yellow one, which is the 8th degree polynomial. That one's pretty good up until about 2.5. Okay, then it starts diverging. So yeah, as you increase that order, what happens is it starts having like closer and closer to the actual behavior of the graph, okay, more long term. But realistically, guys, most of the time we're only interested in the solution around a specific point, okay? Now, obviously, the better the solution, the better that's going to be anyway, okay? All right, other questions, guys? Evan.
If you ask for like a 4th degree, would we have to put in 5?
You could just put in 4. That's fine. I mean, quite honestly, that extra term isn't going to do much. But yeah, if you put in 5, it would give you the 4th order, I suppose. Yeah. Okay. All right, guys. Other questions I can answer. Good question, by the way. Thanks. Okay. Let me show you guys the Laplace stuff, and then we'll be done with this. All right. Laplace stuff is really, geez. Okay. The Laplace stuff is really easy. Okay. So I think on your guys' exam, I had, and correct me if I write this incorrectly, I asked you guys to be able to evaluate e to the 2t 1 plus t squared, Laplace of that. Was that the problem that was on exam 2? I think it was like 3b or something like that.
I think it was just t squared.
1 plus t squared. I think it was, I know it was 1.
It is right.
That's correct. Okay, that's all right.
Oh yeah, that's that one. I thought you were talking about part 2.
Oh, right, gotcha. No, yeah. So that was, I see. I see. That was the one where I asked you to do it by hand. Okay. So let me show you guys how to use MATLAB to be able to do this. Okay. So I'm going to define a Sims variable. I'm going to define S and T as my Sims variables. All right. And I'm going to call F this function. Okay. So I'm going to say exp of 2 times T. So remember in MATLAB, you have to put the multiplication. Apparently it doesn't want me to do this. I don't want the title. Okay. Times 1 plus t square square. So 1 plus t square quantity square. Right. Then what I'm going to do is I'm just going to say Laplace, surprise, of f comma s. Okay. So what that does is it takes the function f and it transforms into s. If you have more than one variable in there, it won't work. Okay, so let me just go ahead and run this and illustrate what's going to happen. What's going on with this stupid command window? There we go. Okay, so let me execute this. I might turn these figures off too. Sorry, I'm going to also. Okay, so here's the answer. Okay, and for those of you guys that got it right, which was a lot of you, by the way, that was the answer that you should end up getting for that. Okay, so It's really nice that MATLAB can do that in like a second, okay? It takes us a few minutes to do it. It's not a terribly difficult problem, okay? Let me close this out and I'm gonna. How come it's not doing well? Oh, I wanted to block out all the code from before so that we don't have to deal with these figures anymore. Okay, there we go. Okay. And I want to block these out so we have more room to look. All right. And then if I want to do an inverse Laplace, okay, let me call capital F. What was the one we had on the exam? It was S minus 1. Was it S squared minus 8S plus 20?
Yeah.
And remember, make sure you put times in there, okay? So what I'm going to do is I'm going to define capital F as that, okay? I'm going to suppress the output, and I'm going to say I Laplace, okay? Capital F, comma, T. So what I'm doing is I'm taking that variable S and I'm transforming it into T. You can put whatever variable you want in there as long as it's a singular variable and it's defined as a Sims variable. All right. The answer was, what was it, like cos 2t e to the minus, it's e to the minus 4t cos 2t plus 3 halves sine 2t e to the minus 4t, something like that. Okay. Okay, e to the 4t, sorry. So here's the answer. It factored it for you. Okay. And that one was not too many people got that one. A lot of people were close, but they forgot to make the numerator S minus 4 as well. Okay, a lot of you guys got the factorization, but then you just forgot to be able to get the do that. Like I think it was the trick where you turn -1 into -4 plus 3. All right, so but look at the solutions online for that one, guys. All right, that's a sneaky one. Okay, if you want to make a really nice output statement, check this out. What you can do is you can define this as A1 for answer 1, and this is A2. And I'm going to say F print F, and I'm going to say the Laplace transform of %S is %S /n, and I'm going to call F comma A1. All right. And then once you have that, you just copy and paste it. And you could say for this one, like the inverse Laplace transform of %S is %F S. I'm going to call this capital F and then A2. Okay, I'm going to go ahead and run that. And we should get a lot nicer output this time. Okay. All right. And there we go. I don't know what. Something happened here. It didn't like it too much. The inverse Laplace. FA1, FA2. Oh, I forgot to, well, it doesn't matter too much. I don't know why that doesn't look good. Let me run again. There we go. Okay, that looks a lot better. I don't know what happened the first time, but what it'll do is it'll write it really nicely. Okay, so that way you guys can see it pretty well for that. Okay. All right. So guys, 3 things I'm asking you guys to do. Okay, so the series solutions, and then from the series solutions, all the graphs. Okay, so everybody good with that? And also the analytic solution. And then that's the hard part. Okay, that's probably worth like 15 out of the 20 points. Okay, and then there's 4 other problems. I asked 2 Laplaces and 2 inverse Laplaces. Okay, I mean literally 4 lines of code, and that's like, or 3 lines excluding the sims. All right, and that's if you want to make it look sexy like this. Okay, so questions, gentlemen. Everybody okay being able to do this sort of thing? Okay, I'm going to post this on Blackboard for you guys. There's also going to be other support videos too. Okay, so you guys should be good